Welcome back to question 7. Let's read it. Joseph is doing a training session. This is the equation h of x, which details his heart rate. We have to fill in the table first of all before we plot the graph. So just plug every value of 0, 2 and 4 and 5 into this equation with your calculator, and we will get the following outputs: 158, 165, 175 and 175. Okay, let's go on to the second part, and we have to draw the graph. So you can see there that it starts at the 158 and you just carry on, and you can see the max points there, okay, the 2 points there at the 175 on either side. So we stop here now at 169. Okay, so what the coordinates A6, 169 represent? So if we go back here, we can see that after the peak there's actually a drop. So that's all you need to do really. It's the first drop from the max. Okay, and we can see that on the graph. So we got to write up the graph now with some information. So the first part is we want to show a plot line which stays at the same level for the next 2 minutes. Okay, let's do that. And decrease at a steady rate. That's important, steady, which would mean very uniform for the next 2 minutes after that. Okay, so let's see. So we have to match up over here with our 2, okay, onto 8 minutes from 6 to 8. But you see, you cannot really go straight across here because we have a curve, and you have to bring it back around. Okay, so you got to bring it back around like that, and then a decrease of 10 BPM for the next 2 minutes. So we're at 170, drop it down to 150 and just line it up then. So you can see here a slight curve here again, because we cannot really go in a straight line. That wouldn't make sense when the graph is already a cubic and we have curvature. Okay, so that's what it would look like. Alright, so on to part D. We have a new formula which measures the calories burned. Okay, so the calories burned is 0.1 h of x, which is the original function, minus 7. We want to find out how many calories will be burnt 6 minutes after the start of the session. So after 6 minutes, the h of x, remember from the plot, is 169. So that's the beats per minute. So all we need to do, our h of 6 is 169. So we have that already. This is more of a composite function because it has 2 functions in one. So you just need to recognize the h of x is from the previous part. So we put in the 169 now, replace the h of x, subtract your 7, and then you'll get 9.9 calories. That's part D. On to part D. Joseph has a smartwatch and it beeps every 15 seconds. The first time it beeps is at 2:55, and then it beeps the last time at 3:23. Work out how many times in total the smartwatch beeps, including the first and last beep. Alright, so let's work out how many minutes are in between 2:23 and 3:23 and 2:55. So 2:55, well, we're going to need 5 minutes to go up to the 3 p.m. and then we need another 23 minutes to get to the final time. So that's a total of 28 minutes. So every 15 seconds we'll give 4 per minute, Okay, so what about the first and last? So therefore there's 4 per minute. That makes sense. So 28 by 4 is 112 beeps. But we will have to add in the last, okay, plus 1. That's the last beep. That's 28 mins. Okay, for 4 per minute plus the last, so that's 113 beeps for his trip. Part F is the final part. So we need to solve this equation h dash of x. So we can see the equation is quadratic format. So therefore we need to use the quadratic formula or the minus b formula. So we can look at the coefficients here, and we have the a, we have the b, over here the coefficient of the x, and the c is the coefficient at the end. Alright, so let's do the minus b formula, as this will give us the time, because remember h dash of x is equal to 0 for max and min. So it's going to get the max in this case. So minus b formula is minus b plus or minus the square root. It's in your log tables, page 25. So b squared minus 4ac over 2a. Alright, so we gotta realize that if this is a real problem now, we just have one solution, because it's going to be on the right hand side. So we're just going to take one of the answers, as the graph was quadratic and it would look like this. So we would just have, we'd have two roots. We'd have x1 and x2. So one of those would be real. Alright, so it'll be the higher one. Okay, so let's put everything in and we get our value. So x is the time, and we go minus b, so that's minus 5.2. And plus and minus the square root, so everything is within the square root now. So we have 5.2 squared minus 4 by the a, which is 1.14 negative, by the c, which is 0.13 negative. Okay, put that into our calculator and divide in by 2 by a, so 2 brackets minus 1.14. Alright, so when we put all that together, we're going to get a result. We're going to get a tiny result of 0.05, and then so we'll omit that and we look at the higher value, 4.536. So that's the true value. So we got to round it to 2 decimal places. So the 36 will push the up to 40.